The first step in solving projectile motion problems is to resolve the initial velocity into both x and y components. In the case in front of us here, we have a yellow vector. The yellow vector is representing the initial velocity of a projectile. You can see here that it is launched with a certain angle to the horizon, or the horizontal. This is given the symbol of theta, and the magnitude of the initial velocity being u. Now we need to get the initial vertical velocity, which is the length of this arrow here, and we give that a symbol of uy, and also the horizontal initial velocity, which is the length of this arrow here, we give that as ux. Now from your mathematics, you know that from your trigonometry that the sine of this angle here is equal to the opposite over the hypotenuse, and we also know that the cos of this angle is the adjacent over the hypotenuse. So writing that down, we have sine theta is equal to uy divided by u. Rearranging the equation, we have uy is equal to u sine theta. On the cos of that angle, we have cos theta is equal to the adjacent, which is ux, divided by u. Rearranging, we have ux is equal to u cos theta. So there we've got an expression for the vertical component of the initial velocity, and we have an expression for the horizontal component of the initial velocity. Most students will just learn those expressions. They associate automatically that y is always with the sine and x is associated with cos, given that that's the angle they give there. It would be a pretty nasty question if they gave you that angle in there, but you know, it could happen. Now, if you do forget about these expressions, what you can do is just redraw this little triangle in your working, and then you can work out that the vertical velocity is sine theta, and the horizontal velocity is going to be associated with the cos theta.